Hi, and welcome to this tutorial. In this tutorial we are going to be making a kind of IronMan-like game mechanic using Unity and the HTC Vive. So as you can see, you can use the controllers to fly over the city and then fire up to vehicles and they react to the hit. Very simple. We are going to be covering the very basics of VR and simple mechanics such as scripting, firing, rigid bodies, and things like that. If you're interested, please stay tuned. So, without further ado, let's get started. First, we launch Unity. And then I'm going to go to Project, New Project. I'm going to call this IronMan. Okay, now this is loaded. First, we want to import the Steam VR package since we are developing for the HTC Vive. So for this, if we don't see the Asset Store window, you go to Window and then Asset Store. You can hit Ctrl 9. Once this is loaded, we are going to look for the Steam VR package. So I'm searching Steam VR. This is the one from Valve. And then I'm gonna click import since I already downloaded it, but for you it will be download first and then import. Then we wait a little bit for it to open the package, and once it's imported, you see that you have the list of all the files that are in this package. We are not going to use the interaction system demo, so just untick this one and click import. Okay, now this is loaded. We are going to first delete the main camera since we are using the one that is provided by Steam. So hit delete, and then I go to Steam VR folder, prefabs, and I drag this camera rig into the hierarchy. And then we are going to first rename this one and call it player rig. To edit the name of the object, you click F2, player rig. Okay, now if we hit apply here, it will update the original prefab of Steam VR. We don't want this. We want to make our own copy. But first, let's make some nice organization for our project. So what I like to do is create a root folder for my whole project, and I call it the same name as the project, IronMan. And then inside of this one, I'm going to create a bunch of other folders to keep the things organized. So first folder is going to be scenes, sorry. Then I'm going to duplicate this, Ctrl D, and enter some other names. Second one is going to be materials. There will be one for scripts, one for music, or I'd say sound, models, and I think that's it for now. Yes, the obvious one is prefabs. Okay. Now that we have this, we can simply drag and drop our prefab in here so it doesn't modify the one that is delivered by Steam. Okay, so now it should be already working. Let's first save the scene, hit Ctrl S, and then go to the scenes folder we created, and let's call this game. Sorry, game. We are making one game now. Okay, so now if I hit play, I should be able to see the things and move the controller. So this is working. Next, what we want to do is provide us with something to stand on. So I'm going to create a simple plane, and I'm going to scale it a bit. And then in order to have physics and to be able to fly in the air, we need the engine to know that we are a rigid body. So let's add a rigid body component. And now if I hit play, you'll see that we are falling to the ground. Why? It's because we don't have any collider attached to us. So in order to remedy to this, we are going to add a box collider, I'd say. And as you can see, if I switch to wireframe mode, the collider is quite big. In fact, you don't want to move all around the place, and it should be a little bit smaller. So I'd like to make it the size of 2 by 0.1, and let's say 2, or even make it 0.01, like this. We can adjust this after, or maybe use a capsule collider or something else, but for now it will do. Now if I go back to shaded mode and hit play, I am standing on the ground. Okay, now we want to fly, of course. So we're going to make a script in the scripts folder. So I go to script, right click, create C# script. I'm going to call this jetpack. And double click to open Visual Studio or Mono Develop if you haven't installed Visual Studio. Sorry. Okay. We don't need these things at first, and I'm going to recreate these afterwards. So first thing we want to do is make a reference to our rigid body. So let's make a private rigid body, and I'm going to call this rigid body. I like to prefix private variables with underscore if they are referring to Unity classes. That's the way I do, but you can do it the way you want. And we also need a reference to the Steam controller. In fact, before we do this, let's first save, go back to Unity, and on the player rig, you see that you have both controllers. The scripts that are the only script that is currently attached is the tracked object. We need to track the events that are happening to the controller. So for this, there is a script called SteamVR Tracked Controller, this one, and I'm gonna add to both. And if I hit play, just to show you, you see that now when I act on the, let's show you the, when I act on the trigger is reacting as well as the pad. For our game, we want the thrusters to be the trigger and the firing of bullets or anything else to be the pad, and the pad pressed event. So let's get back to our script. And now we want to make a reference to this component. So it's the SteamVR, it's the SteamVR Tracked Controller. And I call this controller. Next, we want to assign this when the component is enabled and disabled. Sometimes in VR, when, for example, the controller loses its power, it goes off, so it disappears from the current editor, and we want to be able to track this event. So we are going to use two methods provided by Unity. One is called onEnable. If you are using Visual Studio, you have this IntelliSense completion. When you start to type something and you find the method or the shortcut you want, you simply hit tab and it auto-completes it for you, which is really nice. And the second one is onDisable. Okay, now we are going to make a reference to the controller, reference the instance that is attached to the physical controller. So controller equals get component SteamVR Tracked Controller, And then we want to react to the event when the pad is clicked. So controller dot pad clicked. Remember, this one is the one when I click here, it's pad pressed, but in the script is pad clicked. It's the same. And then we're gonna call a function called handle. Let's say handle pad clicked. Now we need to implement this function. On Visual Studio again, you can simply right click or alt enter and click quick actions and generate method. That will generate the method for you. Or you can simply write this. Don't forget to sign the method correctly. We can remove this, and here I'm just going to, for now, get a pad clicked event on the console. Okay, we then need to unregister when this script, this object is disabled. So controller dot pad clicked minus equals handle pad clicked. Okay. Now just to verify, we go back to Unity, play, and if I show the console, I attach here. Once I click, it should be triggering the event, but it's not. Why? Simply because I forgot to attach the script. So on both objects, I'm going to drag the Jetpack script we created and verify that it's created on both. Yes. And so if I click now, we can see the event is being fired. Good. Now let's make ourselves be able to fly. Let's go back to the script, and we're gonna call first we need to make a reference to the rigid body. So on the start function this time, I'm going to make assign the reference. So rigid body equals get component rigid body. Simple as that. And then what we want is add some force when the trigger is pushed. So I could do this in the update method, but since we are acting with physics, you don't want to use the update method. Instead, you want to use the fixed update method. Why? Because the update method is run not every frame. It's run as the best as the engine can do it. So if a frame takes slightly longer than the other one, then the update method will be slightly delayed. It's not that important for things like, I don't know, firing things or moving things and so, but when you work with physics, it's very important that you modify rigid bodies and things like that on a constant manner. So that's why everything that is being worked with the physics engine has to be put in the fixed update. And you can just imagine how long it can take you the time to troubleshoot these kind of bugs. So we want to make a reference first to the trigger. So the trigger is the button that is below the controller. So I want to be able to read this value. So unfortunately, Steam provides us with nice access to this. So let's say variable thrust equals controller state axis 1 and x. You can read all the documentation in a Steam VR package if you want, but this is the only thing that we're going to use, so it's okay. And what we want is that when we push the trigger slightly, we want to have low emission of thrust, and if I push it all the way through, emit a lot of thrust. So we can control the amount you want to fly. So let's say we don't react if the thrust is less than let's say less than 0.1, and in fact the thrust variable goes from 0 to 1. So 0 is being untouched and 1 is being fully pressed. And what we want to do next is create a vector that will track the force. So force vector, and this one, whoops, and this one is equals to, we want the force to be in the same axis as the controller, so it's transformed forward. So transform that forward, and we want to multiply this by thrust. Since this is a vector in the form of 0, 1, 1 or something like this, and thrust is 0, between 0 and 1, that will not give us much power. So let's put a variable that we can later adjust. Let's say thrust multiplier, and I'm going to create this variable also here, but I'm going to make this one public, float, and let's assign a value of 15 to begin. Now that we have this, we simply need to add the force to our rigid body. So rigid body dot add force, and then force vector. Okay, that should be it. So save the script, go back to Unity and hit play, and we should be able to, if I push the controllers down, to fly. No, because we haven't attached, there is no rigid body on the controller. Why? Because the rigid body is actually on the parent, so the player rig, and we are trying to access it from the Jetpack script. So to remedy to this, it's very simple. When we search for the get component, we want to search for the one in parent. So now it references the correct one. And now it should work. Ah, you see now it's reacting to the force, but it's the opposite way. So to solve this, maybe you can use this that way too, if you want to, but I prefer the IronMan-ish way to doing it. So I put a minus sign, so the vector goes to the other way around. Now if I push upwards, nothing happens, and if I push downwards, yeah, we're flying. Now you see what happened when we land with high velocity, we get through the ground. And one other problem we have is that it's the speed is not constant. So it means at the beginning we go slow, and then we accelerate. And this is something we want to prevent when we are playing with VR, since this can cause motion sickness. All the movements in VR should be like real or instant acceleration or constant movement. Otherwise, it can create some motion sickness. So let's make first that we don't get through the ground. So to do this, I'm going to simply create another script. I'm going to call this one player. And before I forget, I'm going to attach this, when it finishes compiling, to the player rig here, and I'm going to open it. We don't need the generic options, and we don't need the update method. So let's make a reference to the rigid body and assign it equals get component rigid body. Since we are at the same level, it's get component. not get component parent or children. And what we want to do now is first check the position. So I'm going to do this on a fixed update method. And I'm going to say if our current transform position in the y-axis is smaller than 0, so we are below the ground, we want to take the rigid body and move it to the 0 position on the y-axis. So in here I need a vector 3, so new vector 3, and we don't change the x and z axis, just the y, so transform position dot x 0, we keep at 0, and then transform dot position dot z. Okay, that should solve the passing through problem. Let's try it out. Go high, and then I don't cross the ground. Obviously the problem is that if we are even off the ground, I mean not on the plane, we are still staying at level 0. But that's okay for now. Next we want to limit the velocity. So let's go back to our player script and let's comment this out. So it's good command, prevent from passing through the ground. And then let's say limit our velocity. And I'm going to create a variable for this. Let's call this public max velocity equals let's say 10 for now, and I'm gonna say if our rigid body's velocity, that magnitude, which gives us a vector, is higher than max velocity, then the type is a float, my bad. The magnitude gives us a float, not a vector, between 0 and 1, and no, it's not between 0 and 1, it's the magnitude of the speed of the rigid body. So now we want to clamp this magnitude to not go faster than the max velocity. So we say rigid body dot velocity equals vector 3 dot clamp magnitude, and then we say that we want to clamp the rigid body velocity to max velocity, and that should be it. Let's save, go back to Unity, and let's verify that it has a value of 10. Okay, let's make it in fact a value of 2 just to see. So if I go up, it'll go very, very slowly. Okay, so this is working good. Next, we're going to add some nice elements on the environment, because a plane is nice, but it's not very exciting. So for this, I found an asset which is really nice looking. It's called Simple City, I think. And there is a free one if you want to, but the one that I like is this one from Venn Creations. I find it really nice and really optimized and low poly. It's $10. Well, if you don't want, you can pick something else, up to you. So I'm gonna import this quickly. A nice thing, it has vehicles, so we're going to play around with this as well. So I'm gonna click import. Takes some time. Okay, here it is. There is a demo. Yes. Let's first create 2 empty game objects. Let's call the first one city, and a second one that I'm going to call vehicles. And let's add the scene, and let's take all the vehicles that are in the scene. So I'm gonna Control A to select everything, unselect vehicles. So I have all vehicles. I'm simply going to drag and drop them to vehicles. So now if I uncheck this box, you see that I don't have my vehicles inside. This is because I was still in this mode. So instead we want to first uncheck the thing. So let's do it again. So first we are looking for the vehicles. So I select everything and then uncheck the selection box. So they are still being selected, and while they are selected, I unselect my parent and then drag and drop them to this one. So now every vehicle is in its parent, and if I unselect this, they are like this, which is nice. And we're going to do the same almost for the other objects. So I select everything. Maybe I can delete the camera. Directional light as well, we're going to recreate. So select everything and then paste it to city. Okay, and we can unload the other scene and don't save, so we can keep the original one. So to optimize it slightly, I'm going to make these static and change all the children. Once you do this, you start to see that the Unity is working on the calculating the light map. So we don't want this. We go to Window, Lighting, Settings, and simply uncheck Auto Generate, and this will stop the generation, the baking of the lights. And next we want to add some colliders onto these buildings, because currently if we are simply going to, if I try to fly, okay, I go inside the building, which is what we don't want to. And to solve this, we are going to add some let's say some mesh collider. I know this is not the most optimal way of doing it. Maybe in the next video we can make this more optimal, but for now this will do. So selecting everything and hitting mesh collider. So now everything has a mesh collider on it, and we are going to do the same for the vehicles. Except that in this case, since they can be convex shapes, we are going to tick the convex box. And we want vehicles to be able to react to physics, so we're gonna add a rigid body as well. And now if I hit play and take a vehicle, you see that it falls nicely. Okay, that's almost it for the scene. Let's duplicate the light. I'd like to add the 3 lights here, and let's turn them around a bit so that I have a nice scene light like this. Okay, and I'm going to lower the intensity just a bit, maybe 0.8 should do. In fact, 1 is good. 1 is good. Okay, save this. Now we are flying, which is good, but we need to have some nice particles or smoke that is coming out from our models. And in fact, now the models being just steam models is not really nice looking. So we're going to make a particle system for this. So let's go to the controller. I'm going to create a particle system. So game object, effects, particle system. So you see that it doesn't look that sexy for now. What we're going to do is first generate a mesh that we're going to use as a smoke object. For this, I like to use a Blender, and I think it's a really nice tool. I'm by far not an expert on 3D, but I think it's a really nice software and quite easy to use. There is certainly a long learning curve for this, but what we're going to do is pretty simple, so I suggest that you give it a try. So go to blender.org and download Blender. Once you launch it, you have this window. Just click around, and then you say, we click A few times to select everything, or you can go to select, I think, all, yes. And then hit X to delete and confirm with OK. So now we have an empty scene and we are going to add an object. So it's Shift A, or you can go from here, add mesh, and then we are going to add an icosphere. And the one that is provided is perfect for us. We can move it around if you want to. And next we are going to center this on the scene. So while this object is selected, I click the N key, and then you see that the location is at a weird place, and if I move it, you see the location moves. So I'm going to zero it out. And then next we need the dimensions to be also the same. So I hit Ctrl A this time, and we say apply location, rotation and scale. So now the shape is fixed and the scale is 1. And now we need to export this out. So I go to File, Export, FBX, and then I go to the folder where I have my models, which is on the IronMan folder, Assets, IronMan, and Models. And here I'm going to call this, Smoke. And then that's it for now. Okay, we can close Blender. If you don't have Blender or you don't want to use it or so, I will be putting a link to all the 3D objects that we are working on in this tutorial, as well as the sound, in the link of this, in the description of this video if you want to download them. So now if we go back to our models folder, on our models folder, you see that we have the smoke folder, the smoke object, and this is the one that we created in Blender. It's nicely looking. Next, we want to associate this with the particle system. So first we can delete it. And then back to our particle system. Down, I'm going to close the console. Down, you have a renderer tab. I'm going to click it, and I'm going to change the render mode, not to billboard, which is to the sprite effect by a mesh. And now you see that it's rendering its default cube, but we don't want this. We want to render our mesh. So back to the models and the smoke, you have an icosphere. This is the one we created. I'm going to take it and put it back in the mesh place. Now you see that it's not emitting anymore. Well, it is, but it's using a material that is for 2D, and we are rendering a mesh, so it will not work. So we have to create a material for this first. Going to the materials folder and create a material. And I'm going to call this smoke. One thing you notice is that each time you export an FBX in Blender, it creates the model, but it also creates a material folder. And we don't need this now, so I'm going to simply delete it. Now back to our particle system. In the renderer, I'm going to assign our smoke material to the material of the particle system. And now you see it's rendering, but the smoke is really small. So here, at the very beginning, you can adjust the size of the particles being spawned, and this is just a thing to play around. So let's say start size of 3, or maybe 10. Let's say even 20. Okay, that looks okay, maybe too big. Let's say 15, and we'll change this around. The shape is not good as well, because we are not emitting like a cone. So we go to the shape tab, and we want to emit like an edge, because this is a really small thing, and we are going to change the orientation to 0, so it faces up just for now. It's almost looking good, I would say. There is not enough particles. We can add them. First, let's reduce the edge to the minimal size. Okay. And let's reduce the lifetime as well, because like that's a lot of smoke. And let's say 1, or even smaller, let's say 0.5 seconds. That should be enough. And our particles have all the same size, which is not what we want. So let's go to particle system, and there is a tab for this, and it's called size over lifetime. And then we can adjust this. If you're using Unity 2017 1, there is a bug, or I don't know where it went, but you cannot edit the curves here. Instead, you have to go to the editor, particle system editor, and then you can see the actual curve edition. So here we are going to make the particles. Let me put it here so we see what it's doing. So they start small and they go big. We want the opposite. They start big and then go small, and we can adjust the curve by double clicking and adding a control point, and playing around with the size and things like this. I leave it up to you to customize it to your needs. One other thing is, I'm going to close this up now. If we move the particle system around, it moves with it, which is not what we want. So the simulation space should be world. So, whoops. So when you move around, particles emit but stay in their worlds and in the world space. Next, we can make them a little bit nicer looking, like we are going to change the shader that they are using, because now we are rendering 3D object, but it's well, it can be a style. But I'm going to go to the smoke material and change the shader to be particles additive, and now you see that it's actually transparent. Let's add some color. Let's go to color over lifetime, edit this one, and then I think they're going to start from red and then go to yellowish. Where is the yellow? Here. Okay. That is looking nice. And what we can do now is change the rate of emission just to see how much more it affects. Okay, 30 is really nice looking. Yeah, I like it. Maybe even shorten the lifetime, 0.3, something like this. Yeah, okay. So you can always play around with this to customize it to your needs. You can also adjust the speed and things like this. Anyway, let's leave it for now. Let's then attach these particle system to the controllers. So here, make sure that it's zeroed out, so it's on the controller, and then we duplicate and we put it on the right controller as well, and remove the one side. So let's see how this plays now. It's nice, but as you can see, we have a rotation problem. The thruster is not on the axis of the controller. So let's take the controllers and see what we can do. I think it's a 90-ish rotation. Yes. So let's select them both and it's 90. Okay, so now this is looking already better. It's also, yeah, it's at least facing the right direction. I go too slow. Let's adjust our velocity, maximum velocity. Let's make it to 10. And let me put the headset just to see how this feels at 10. Okay, I think it's nice. It's not too fast. Okay, yeah, it's good. Now, oh, okay. See what's happening now? We are turning all the way around. This is because we haven't put a fixed rotation to the rigid body. This is easy to remedy. We go to the rigid body of the player and we say that we put the constraints on the rotation X, Y, and Z axis, so we don't rotate anymore. And thankfully this is a nice thing that we spotted this bug. Okay, now it would be nice if our little thrusters work only when we hit when we press the trigger. So let's work that out. Let's go to the jetpack script. In fact, this should be called thruster. Maybe I will rename this. And let's reference, let's make a variable to access the particle system. So let's call this private particle system. And I'm going to call this particle, yeah, particles, or let's call this thrust. Yeah, thrust is good. So let's assign it on the start, no, not the start method, on the unenable, because if the controller is disabled, we will not have access to the particle system. So thrust equals get component in children. Why? Because the jetpack script is on the controller object, and we want to access the particle system, which is a child of the controller object. So that's why you put get component in children and then particle system. Okay, and now we want to be able to act on this when we push the thrust. So let's say thrust that emission rate equals thrust that multiplied by let's say thrust emission rate, and I'm going to set this variable at the top and say public float emission rate to be what we have now. Is like 30 is good. Okay, so when I push the thrust, which is a value between 0 and 1, the emission rate will be 0 and 1 multiplied by thrust. So if it's 1, it's 30. And if we don't press the thrust button, I'd like to stop anything. So thrust that emission rate, oops, equals 0. We can put like, I don't know, a value of 3 if we want to cool to have a small effect, but you can, up to you. Let's see if this now works. We don't have anything to assign, just check that the thrust emission rate is correct. We can also apply our prefab and let's play. So I'm not pushing anything, I'm pushing it slightly, so it's emitting a small amount, and I'm pushing it fully, it's a full amount. Okay, this is looking good so far, sorry. What we want now is to remove this ugly model of the controller and put our own instead. I already did one in Blender, and if you want you can use that one. It will be linked into the description. So I made a thruster one, so I'm gonna put it here, delete the material, maybe not. I'm gonna take the no-name material and call it thruster, because that's the one that's assigned with it, and put it on my folder, and then delete this empty folder. Now that we have our thrusters, let's put them on each controller. I think we'll have to adjust a lot of the settings here, but first let's see how it is looking. Wow, it's so huge that I cannot see myself. So let's make it a size of both. You know what, let's edit the model itself and change the scale to 0.5, and let's see how this is. Still too big. Let's make it 0.1, so 10 times smaller than the original, and now I think this is too small. Let's make it 0.25. Okay, and I think we also need to rotate it, but just let's see first. Okay, now it's too big. Let's say let's make it of size 0.2, just like that. And here the thruster, I think the rotation it should be 0, but I'm not sure. Yes, that's it. They are quite big now. Oh, it's always a game of adjustments. Let's make it 80. Okay, and then you can work it out later on. Okay, this size is good. The only thing is that I need to remove. No, the model is okay. So basically, we have our thrusters. We can take off with a single one, and if I take the other one, it's here. Sorry, I can use them to fly around. Yeah. Okay. It's looking fun. Now, let's make so we can fire at these vehicles so they can fly all over the place. First, let's get rid of the model once and for all, and hit apply to our prefab and save. And then we are going to create a kind of game manager for our little game. In this we can manage things like scoring and fuel level, I don't know, things like this. So for now I'm just going to make a reference to the weapon that we have. So I'm going to create an empty game object, zero it out, and create let's say game manager script, and create an add. If you do this, it will not create the script in the script object, but instead in the root of the assets folder. So you want to take the script back and put it on the scripts folder. And now we want to open that up. And next we want to get rid of the generic and collections that we are not going to use. And I'm going to delete those as well. What we want now is make a static reference to this class. So each time we need to reference the game manager, we don't make a link in a field. Like if I were to go here and say public game manager, first I have to save it, and then here game manager. Why it's not working? should be, but never mind. Okay, sorry for that. So let's create our first reference to this class. So this is going to be a public static variable of type game manager, and I'm going to call this instance. And in the awake method, it's void awake. I don't know why IntelliSense is not working here. Okay, I'm going to say if instance equals null, then we want the instance to reference this class. Otherwise, if the instance is not equal to this, so there is another game manager instance in the scene, we want to destroy ourselves. Destroy game object. I don't know why IntelliSense is not working, but anyway. So game manager is here. Let it recompile. Maybe it didn't have time to recompile, that's why it was not working. Let's try it again, just make sure. Game, no, still not here. Okay. Anyway, we are simply going here to make reference to like an ammo. So public game object ammo prefab. Okay. And then we back to Unity. We are going to create our little weapon. So let's say we are going to create a small sphere. Okay, simple. And I'm gonna make it react to physics. So just add a rigid body. And let's call this ammo. And let's make it a prefab. So selecting it and dropping it into the prefabs folder. And then I can delete it. Now on the game object that we are assigned, we're going to call this game manager and simply going to drop the ammo prefab in here. Okay, and now we want to be able to fire, so let's go to the jetpack tool and say that when we click on the pad on the controller we want to fire. So in here we are going to say that we are going to instantiate a game object. So game object ammo equals instantiate what? We're instantiating the ammo prefab that is referenced on the game manager script. So to access this, it's simply now game manager dot instance. It doesn't exist in the current context. I don't need system, by the way. Why it's not working? Game manager static. This works. Is there another game manager script? No, I'm the only one. Let's do this. Sometimes it's not working, so let's select the game manager class. I'm going to copy all the scripts and go back to Unity and delete it. Delete, yes. And then from the scripts folder, I'm going to create it here and wait for it to recompile. Okay, and now edit it back. Okay, and select everything and paste. And now it should be compiling without any errors. Okay, and go back to Jetpack script, and now here game manager. Okay, so sorry for that. So instantiating the ammo, so game manager, game object ammo equals instantiate and then we reference our class GameManager.instance.AmmoPrefab, and then where we want to spawn it, let's say we want to spawn it at the same place as the controller for now. Let's say transform.position, and the rotation we don't care, so we put it at the same orientation as the prefab is, and then as GameObject. Finally, we want to add some force to this newly generated object, so ammo.getComponent. We want to access the rigid body component, and then we are going to add a force, and then the direction of the force will be the forward direction of the transform, so it's going to be transform forward, and then I'm gonna give this force, let's say 100, and then force mode to be impulse. So everything is delivered in one action. Normally you should do this in a fixed update method, but since we are only doing this once, like in a single frame, it's okay to put it elsewhere. If you want to act on something that repeats over frames, it's good to put it on the fixed update method. So that should be it, and now we should be able to fire. Where's my controller? Here. It doesn't fire. Why? There is no object reference. So let's go back to yeah, because we removed the script. So Game Manager, drag it back and put back our prefab. Okay. Yes, now it's working. Balls are sticking, and if I hit a vehicle, they fly all over place. Okay, so I think that's it for now. We have a basic working game, and maybe later we can add some other things that can be interesting, like destroying the buildings or destroying the vehicles, having some I don't know, some other things around, walking, I don't know. If you have any idea, just let me know in the comments, and if you have any questions or so, please don't hesitate to write me down a comment. And if you like this video, please like it and subscribe if you want me to do some other videos. Thank you for watching. Oh, one last thing, I will put a link to all these different assets that we had, and maybe in the next video I will show you how to put the sound effect within the game. Thank you, bye.